Hi, welcome. In this video, we will solve problem jump game asked by companies like Amazon, Microsoft, Facebook, Google. Let's check out this problem jump game. Again, one of the most important problem on greedy jump game. Okay, you can see different types of patterns on the basis of jump game. Okay, there are different variations available on Leetcode, jump game 2, jump game 3, and so on. Okay, so that's why this problem becomes the fundamental problem on greedy. Okay, and by solving this, you will get to know how basically greedy works. Okay, again, before starting, I always suggest you greedy, it's not a conceptual thing that you will come with some strong concepts like is there any technique. Greedy is basically about greedy things, right? You are just using your logic, you are finding out the best possible solution, most optimal solution, and that's approach is the greedy approach. Okay, so now let's see this problem. So you are given an integer array nums. You are initially positioned at the array's first index. So you are at the first index. Okay. And each element in the array represents your maximum jump length at that position. Okay. That means the maximum jump from here you can do, that is 2. Max jump. That means you can do one jump as well, right? Or you can do as 0 jump, but the maximum jump that you can do, that is 2. Like similarly here, that is 3. That means the maximum jump that you can do is 3. So if I say what will be the maximum jump, that is 3 here. This is 3. But I can do this one jump, as well as this one jump, right? These are all the possibilities I have. Similarly, when I am at 2, I can do this jump, 1 or 2 jump, right? So this is the jump limit, the position. Return true if you can reach the last index, or false otherwise. So basically we just need to check if by these jumps can we reach to the last index or not. Okay, so suppose you are here. Okay, and what are the possible jumps that you can do? You can either take one jump or you can take two jump. Okay, suppose you have taken two jumps. Okay, then you have a chance of taking one more jump. Okay, and then you can take one more jump and you will be at the last index. Okay, suppose instead of two jumps you have taken only a single jump, and then you can take a three jump. Simple, three jump you can reach here, or you can take a one jump, then you can take again one jump, then you can take a one jump. So the output of this problem will be true, that anyhow you can move to this fourth, this last index. Okay, the 4 position. Okay, now let's check out this one. We have 32104. So how many jumps I can do it from here? I can do one jump, I can do two jump, and I can do three jump. So the maximum position that I can jump, that is the position here, that is 0. Okay, and from here I can't do any jump because the value is 0. So that means 0 jump I can do here. Okay, that is no jump. So let's suppose I have taken one jump, and from here, what are the possibilities? So I can either take one jump or I can take two jump. But even if I'm taking the maximum jump, I am reaching to the 0 position only. Even like let's start from 1. Even if I'm taking one jump, I am reaching to this position only, that is 0. So there is no possibility that I can move beyond 0, right? I can move beyond 0. The only position that I can reach, that is 0. And from here, I can't do any jump. So that means here I can't reach. I can't reach to the last index, and that's why the answer is false. Okay. So now let's understand it a bit of more clear sense, and then we will come up with logics. Okay. Let me fill with the data. So we have 2, 3, 1, 1, and 4. Okay. Again, let's say this is as nums, and let me write the indexes 0, 1, 2, 3, 4. So you are at here. Okay, and you need to reach to the last index, right? This is our the last point I will say. Okay, this is I want to reach. So basically, what are the possibilities? That you can either take two jumps. Okay, from here you can either take one jump or two jump or three jump, right? From here you can take only one jump, and you can reach to that position. Now think in this direction. Let's take one more example to understand it much more better. I'm simply mentioning 0 here. Okay. So I have 2, 3, 1, and let's suppose 0 and 4. Okay. And let me write the indexes, that is 0, 1, 2, 3, 4. So now from here, I can do the maximum jump I can take, that is 2. Okay. And from here, I can take one jump. I am reaching to 0. Now, suppose instead of 2 jump, I am taking only a single jump, that is this one jump. And from here, I have a possibility that either I can take one jump, but if I am taking one jump, I will be end up with 0. Okay. If I am taking 2 jump, I will be end up in 0. If I am taking 3 jump here, then I will reach to this position. So by taking a 3 jump from here, I am surpassing this position, that is 0. Okay. And once I surpass this 0, I will be at, I can move to the last element, right? I can reach to it. And that's why it will be a true case. So that means the only thing you need to figure out, think in this direction. If there are only elements there, right? If there are numbers, not 0. Okay. Suppose positive numbers only. Positive numbers only. When there are positive numbers only, is there any chance that you won't be able to reach to the last element? If there are positive elements only? No, there is no chance that you won't be able to reach to the last element. See, suppose if all the elements are 1, 1, 1, right? All the numbers are very less but positive. Okay. So even if you are taking one jump, you will be easily achieve the last element. Until and unless if there is present a 0, right? Suppose there is a 0, right? So we have discussed this case. Okay, let me create one more case. If there is a 0 in between, suppose like this. Okay, all the values are. So from here, you will reach to the 0 position, and from here you can't jump. So can I say, like, will you be able to reach to the last element? Will it possible? No, not possible, because there is 1 0. So whenever there is 1 0 mentioned, there can be either true or false. But if there are only positive numbers, can I directly say the answer will be true only? For sure, right? There will be an answer true only. But if the 0 is present, okay, then there is a possibility it can be either true or false. Like we have checked in this case, for some, like in some of the path, we were end up in this position. But by taking this path, this one from 2 to 3, and from taking a 3-step jump from 3, we will end up reaching to the last element. Right. Okay. Now we need to understand how we will figure out this way, right? How we will figure out this way. Now again, let's understand by the observations. We will solve more and more problems, and then we will check. So let's see, if I'm taking one example, 3, 2, 1, 0, 4. Okay. So the maximum jump, okay, let me write the indexes 0, 1, 2, 3, 4. Okay. So the maximum jump I can reach from 3, that is 0, 1, 2, 3. Okay. If I am at here, the maximum jump I can reach, that is this one. If I am at here, the maximum jump I can reach, that is here. So is there any way that you can surpass this 0? By all the possible options, by all the possible path, you are end up in at the 0, right? So can I say the my maximum index, okay, that I can achieve, my maximum index that I can achieve, that is 3, and that's why it is not possible here. Okay, so you need to find out the maximum index, okay, that you can achieve by the jumps. How we will do it? Let's see, let's try it. But are you getting a sum of sense, like why we want maximum, why there is an importance of 0? Okay, Why, like if there are only positive numbers, then we can directly say that is true. Why I'm saying maximum index, you need to find maximum index, the maximum limit that you can achieve. Suppose I am saying, like I am saying that I can reach to 3. Okay, I can reach to 3. So that is the only thing that I can reach it here, right? Either I can taking one step, suppose one step from here, then one is jump, then one jump. Still I am reaching to 3. That's the only end for me. So basically, if I am finding the maximum index, I am finding the end point. What is the end point of it? Let's understand this with a better example. So suppose I have 1, 2, 2, 1, 1, 0, and let's 4 and 5. 0, 1, 2, 3, 4, 5, 6, 7. First of all, tell me, is it possible to reach this position? Okay, let's understand. Again, how we will understand? That's how we will develop the approach. So this is my nums of array. How I will find? Again, how what I said, I will find the maximum index. The maximum index I can reach. If my maximum index is greater than this 0, yes, I can surely achieve that, right? So let's suppose you are at here, right? You will always start from 0. So the maximum index right now you can achieve, that is 0. Can I say? Because you have started from 0. Yes, maximum index you can achieve, that is 0. Okay. So now what will be your jump? That will be your index. Okay, that is I plus, I can say nums of I, right? I plus nums of I will be your jump, right? So what is I plus nums of I? That is 1 plus 0 will be 1. So the maximum index that you can achieve from here, that will be 1. Yes, that will be 1. So now I will be here, my maximum index will be here. Okay. Now from here, what is the maximum distance that you can achieve, maximum index? Okay, again I plus nums. So what is I? That is 1. What is nums of I? That is 1 plus 2, that is 3, right? So you can achieve from here, that is 3. You can move to this one, right? So I will update it 3, right? But I will check all the possibilities, right? So I will update this 3, right? But I will check this one too. Okay, that maximum achieve it 3. I'll check with this one. What is the maximum distance maximum index I can achieve? I is at 2. Uh, nums of value is 2. 2 plus 2, that is 4. Okay. Yes. So the maximum index is now 4. That means you can achieve here. Okay. No matter. Let's move ahead. I will check this one. Okay. What is the maximum index that you can achieve? I is 3 plus 1. 3 plus 1, 4. Okay. No matter. So even if you are taking one jump from here, or you can take a 2 jump from here, you are reaching to the same index. So your maximum is still 4. No matter. Let's move ahead. Now you are at here. Okay. What is the maximum index you can achieve? 1 plus 4, that is 5. Okay. So you can achieve maximum 5. So now my maximum is 5. Okay. Now I will come here. What is the maximum index that you can achieve from here? That is 0 plus 5. That is again 5, again equal to my maximum. No need to update. Now I will come here, and now let's see, there is a point. Now once I come here, what will be my maximum nums of I 6 plus nums of I, 6 plus 4, 10. That means I can move to 10th index. Okay. But but what is the maximum index that we have achieved so far? That is 5th. So the 5th index is the maximum index you have achieved. How you can start traversing from 6? How you can take a jump from 6? Because the maximum index as of now you can achieve, that is 5. So if your I, like if your I whenever is greater than your maximum achieve index, okay, what you will do, you will simply say return false, because you are saying the maximum index that you can achieve, that is 5. Okay, and you are starting from 6. How it is possible? Not possible. So you will directly say false. So this will only true till your I is less than or equal to maximum. Like in all these cases, you can check your I is less than your maximum. So here your maximum was 0. You started with 1 plus 0. So your maximum become 1. then you started with 1, right? So 1 1 1 equal, then it was 2, you have 3, right? Then it was 3, you have 3, okay. Then it was 1, yes, you have 4, it's okay. Then it was 5, it's okay, right? Like 4 and 5, all these indexes are under your maximum index. Let's understand this one more example. This was a false case, let's understand with a true case. Okay, so in for a true case, what I will do, let's tweak our arrays, like 2 1 4 1 1, and let's make it the 0 and 3 comma 2, again nearly same example. So 0 1 2 3 4 5 6 7. First of all, tell me, like, is it possible to achieve to the last element? We have 0. So let's see, suppose if you are here, you are taking a 2 jump from here, and then you are taking a 4 jump. So 1 2 3 4, the fourth jump will be here. Okay, and then yes, you can achieve to the last element. Now let's see how this is appear, right? How this is appear. And remember, here you will find your I is always less than or equal to your maximum index achieved so far. Okay, so let's start the maximum index. So maximum index as of now, that is 0, because I'm starting from here, 0. And what will be I plus nums of I? Again, all these values are I. Okay, I plus nums of I. So I at 0, yes, maximum index is equals to 0. So 0 plus nums of I, 0 plus 2, that is 2. So maximum index is now 2. Okay, and you will check this. What is the maximum index you can achieve? 1 plus 1, 2, which is equal to maximum. Okay, no worries. Then 2 plus 4, again you are taking 2 because your maximum index is 2. So 2 plus 4, that is 6. So the maximum index you can achieve, that is 6. Okay, now there is 3 plus 1. Yes, you can take 3 because 3 is under 6. So 3 plus 1, 4. Okay, so the maximum index from here you can achieve, that is 4. That's okay because you are under 6. Now 4 plus 1, that is 5. Okay, the maximum index you can achieve, that is 5. And this is under your maximum index, that is 6. So this is okay. Now this is 0 plus, sorry, 5 plus 0. 5 plus 0, that will be 5. Again, you are under maximum index, so that is possible. Now, let's see. Now you will get it. Now, when you are here, you are writing 6 plus 3. Okay. Now, 6 plus 3, that is equals to 9. Okay. You can write this because the maximum index you have achieved so far, 6. So that means, yes, you can take a jump from here. No worries. So 6 plus 3, that is 9. And since your I plus nums of I plus some nums of I, can I say that this sum 9 is greater than your n minus 1? What is n here? N is 8. 8 minus 1, that is 7. N minus 1 here. So n minus 1, that means 7. So yes, it is greater. That means you can achieve it. I can directly say that return true. And yes, that's why the output will be true. So basically, how we will solve it, what will be the pseudo code of it? So basically, I will start one loop, okay, that will start from 0 and it will run till nums of length, okay, nums dot length. Now inside this loop, okay, I will write certain condition. First of all, I will always start my maximum. Okay, let's suppose maximum is maximum index. I'm starting with 0. Okay, if at any point, okay, if at any point, if my I is greater than maximum, I should directly return false, right? Because that is not possible if your I is greater than your maximum index. Okay, now this is not the case. Then what will be the case? I plus nums of I, if I plus nums of I is greater than your maximum, so what you will do, you will update your max equals to nums of I plus I. Okay, and in the last, if everything goes fine, in the last you can return true. Also, like if you want to put any condition, so you can put if your maximum, okay, is greater than your n minus 1, simple, so directly return true. So you will get result in like more 2-3 iterations before. Okay, so again, like you will get this simple result by true only, but like if you want, you can get the result by uh, adding one condition. And what will the time complexity of this approach? So the time complexity of this approach, like you are starting from 0 to nums of depth length, so it is directly proportional to length of the array, so that is n. So here the time complexity will be big O of n only, and space complexity will be big O of 1. You are not taking any extra space. Okay, so basically how I find out this solution. Okay, so this is what greedy is. I I become greedy. Okay, I become greedy about maximum index. Okay, what is the maximum index that I can achieve? So I am not checking like all the possible solutions. Like if I am taking one jump, then suppose if I'm taking two jump, three jump, will I be possible? I'm just going greedy on this thing. What will the maximum achieve index that I can achieve? And if there is any pointer, okay, which is greater than maximum index, that means I can't reach to that point. So that's simply a false. Okay, so this is how you will solve this problem. In the next video, we will see the code implementation of it. Okay, so I will simply show you the code implementation part of it, and then in the next we will do a quick dry run of this problem.